Picture a family planning a big dinner. One option is a single master grocery list stuck to the fridge, so when mom crosses off milk, everyone instantly sees the truth, but they all have to walk to the kitchen to check it. The other option is to text a copy of the list to all 5 phones so nobody has to get up, which is wonderfully fast until dad buys the milk, grandma still sees it on her phone, and the kids come home with 3 extra cartons. One way is slower, but always honest. The other is quick, but quietly drifts into chaos unless someone keeps every copy updated. That very choice, one shared truth versus fast, convenient copies, is the heart of normalization versus denormalization. Say you store a customer's address inside every order they place. The customer moves. Now you have 10 old orders with the old address and the new orders with the new one, which is correct. You also waste space repeating the same address, and updating it means touching 10 rows instead of 1. This is the cost of duplicating data carelessly. Normalization is the practice of organizing data so every fact lives in exactly one place. You split data into separate tables and link them with foreign keys, so a customer's address is stored once in a customer's table and referenced by every order. Denormalization is the deliberate opposite, copying related data together to avoid joins and make reads faster. Both are tools, and the art is knowing when each one pays off. Normalization breaks data into tables where each table describes one kind of thing, like customers, orders, and products. Each row gets a primary key, a unique ID, and other tables point to it with a foreign key instead of copying its data. This guarantees one source of truth, so updating a customer's email changes it everywhere at once with a single write. The cost is that answering a question often requires joining several tables back together at read time, which takes work. Denormalization copies frequently read data into the same place, like storing the customer name directly on the order so the order's list needs no join. This makes reads faster and simpler, but now the same fact lives in 2 places and can drift out of sync. To keep denormalized copies correct, you must update every copy together, often with triggers, application logic, or a background job. The practical rule is normalize first for correctness, then denormalize specific hot paths only after you measure a real read bottleneck. A relational e-commerce database normalizes. Orders store a customer_ID, not the customer's name and address. To show an order, you join orders to customers. But the order's line items deliberately denormalize the product price at purchase time, copying it into the order row. That is correct on purpose, because the price the customer paid must never change even when the product's current price does later. MongoDB takes denormalization further by embedding, storing the whole order with its items in one document, so the read is a single fetch. The first misconception is that normalization is always right. Over-normalizing can force a single screen to join 8 tables, which is slow and complex. The second is that denormalization is just laziness. Done deliberately and maintained, it is a legitimate performance optimization. A third is forgetting that denormalized data needs a strategy to stay consistent. If you copy a customer name onto orders and never update those copies, your data lies. People also assume NoSQL means you skip this decision, but embedding versus referencing in MongoDB is the exact same normalization trade-off wearing different clothes. It is the fridge list versus the 5 texted copies. Normalize so each fact lives once and stays correct. Then denormalize specific read-heavy paths on purpose, accepting that you must keep the copies in sync. It is correctness versus read speed, and you choose per case. I turn one data modeling decision into something obvious every single day. So subscribe to TechWithJoel. Have you ever been burned by duplicated data that drifted out of sync? Tell me below. Subscribe to TechWithJoel.